Hi children, now we are going to learn definition of the logarithm. Let a comma n are two positive real numbers belongs to R plus. A comma n belongs to R plus are any two positive real numbers, and also a not equal to 1. If x is any real number such that if x belongs to R, that means x is any real number such that a power x is equal to n, a power x is equal to n, then x is called logarithm of the n to the base a. How can we say the x? X is called, this x is called logarithm of n to the base a. It is denoted log n to the base a. This is equal to x. Again children, definition of the logarithm is, let a comma n be any two positive real numbers and restriction is given to the a not equal to 1. If x belongs to R, any real number, if x is any real number such that a power x is equal to n, then x is called logarithm of the n to the base a. It is nothing but x. This form is known as the logarithmic form. Here observe the children, here we are making x as the subject, but whereas it is not possible in exponential form. This a power x is equal to n is the exponential form. Here in this exponential form, we can make a as the subject, but we can't make x as the subject. But in logarithmic form, we can make x as the subject also. But if you observe the definition, what is the need to restrict a not to 1? And what is the need to restrict a comma n positive real numbers only? These two are very important points, because of, if you observe the exponential forms converting into logarithmic forms, 3 square is equal to 9. That implies that I can make 2 as the subject using the logarithmic definition. I can write this is as 2 is equals to log 9 to the base 3. Is it correct or not according to the definition? Yes, it is a correct. But when the base is 1, what happened? We know that 1 square is equal to 1, 1 cube is equal to 1. Are these exponential forms or not? Yes, these are all exponential forms. Write them in logarithmic forms. Then I can write log 1 to the base 1 is equal to 2. That implies that log 1 to the base 1 is equal to 3. And what do you observe? Here and there also log 1 to the base 1 is there. LHSs are equal, but RHS are not equal. Here 2 is there, here 3 is there. Therefore, log 1 to the base 1 is not properly defined, not defined particularly. So that need to restrict this base of the logarithm not equal to 1. Is it clear to children? This is the reason. What is the need to restrict a not equal to 1? And what is the need to restrict a comma n belongs to positive real numbers only? Why? Because of, here also we can see (3 square is equal to 9). Minus 3 whole square is also 9. and convert this is into logarithmic form. Log 9 to the base 3 is equal to 2. Here this is log 9 to the base minus 3 is equal to 2. Here what do you observe? This is 2, this is also 2. Results are equal, but whereas logarithmic forms are different. Log 9 to the base 3 is equal to log 9 to the base minus 3. Are these two equal? If you accept these two are equal, automatically 3 equals to minus 3. That ambiguity will be there if you accept negative real numbers also in the definition. So that base should not be 1 and base should not be negatives also. In higher classes, we are going to learn logarithmic function, why it is called as the logarithmic function, and in that we will get the clarity, not by taking the examples, we will get the theoretical clarity also in higher classes, because of logarithmic function is a inverse function. So the children, here in this class 8th, it is enough to learn why a not equal to 1 in the definition of the logarithms, and by taking examples we can get the clarity. Already we saw why this a need to be restricted positive real numbers only, that also we got by these two examples. So that here negatives are restricted in the logarithms as the bases. After learning the logarithmic definition, by restricting the base to positive real numbers and base not equal to 1, and what is the need to restrict n belongs to r plus result, that means log n to the base a is equal to x. Here n is always positive. Why? Because of a power x is always positive. Since a is positive real number, x is any real number, then this value always positive. No need to give any restriction to the n. N is always positive real number. The result is always positive real number in this exponential form. That's why n also belongs to r plus. Now children, after learning the definition, we are able to give the reasons why a not equal to 1 and why a belongs to r plus. Is it clear to all? Okay. Now come to the logarithmic forms into exponential forms into logarithmic forms. I am going to take one example. 3 power 4 is equals to 81. And what is its logarithmic form? That implies that log 81 to the base 3 is equal to 4. Both expresses the same relation, but both express the same relation, but the forms are different. The way of expressions are different. Here result is the subject, here exponent is the subject, that is power is the subject, that is only the different. Now we have to know how to convert the logarithmic forms into exponential forms and exponential forms into logarithmic forms. Some properties are there for the logarithms. That means the first property is properties of logarithms. We need to remember these properties while using the logarithms. The first property is logarithm of the non-positive real numbers is not defined under the real numbers. That means logarithm of -1 to the base 10 is not defined. Is not defined. Why? Because of under the real numbers. I am stressing children, under the real numbers logarithm of minus 1 to the base 10 is not defined, because of if you take log minus 1 to the base 10 is equals to some x, 10 power x is equal to minus 1. Is it possible, children? Not possible, because of we can't get any x such that the positive power of the positive number never be negative. So that, but here 10 power x is equals to negative is there, therefore there is no possibility of the x. That's why this logarithm of non-negative, non-positive numbers, non-positive real numbers are not defined. This is very important. Logarithm of non-positive real numbers are not defined under real numbers. Whereas if you go to the complex numbers, you can see the answer also for this. But under real numbers, logarithm of minus 1 to the base 10 is not defined. This is an example. Now come to the second property. Logarithm of same numbers with different bases are not equal. Log 8 to the base 2 not equal to log 8 to the base 3. These two are not equal. Here what do you observe, children? Logarithm of the same number is there, log 8 is there, but the bases are different. Here 2 is there, here 3 is there. So that if you suppose if there is an existing of if these two are equal, if you take these two are equal, then let it be some x, then x, write it in exponential form. 2 power x is equal to 8 and also 3 power x is equal to 8. Therefore 2 power x is equal to 3 power x. Is it possible? 2 power x is equal to 3 power 8. Possible at x equals to 0. Okay. Substitute x equals to 0 here. 2 power 0, 1, 3 power 0, 1. Is 1 equal to 8? Is 1 equal to 8? No. So that x is not possible. Therefore, we can get one more property, that is logarithm of same numbers with different bases are not equal. Okay, na children. Now come to the next one. This is not equal. Finally, what we obtained here is these two are not equal. Third property, property number 3. Now, logarithm of the different numbers with the same basis, that is log 9 to the base 3, log 8 to the base 3. Are these two equal or not? Once check it. Let it be, suppose if these two are equal, let it be equal, is equal to x, then what do you get? 3 power x is equal to 9, 3 power x is equal to 8. That is equal to 9 is equal to 8. Is it possible, children? Is it possible? This is false. That's why logarithm of the different numbers with the same base are not equal. Now come to the fourth property. Logarithm of the number with the same base is equal to 1, that is log a to the base a is equal to 1. Where here need to restrict, what about a? A belongs to r plus and a not equal to 1 also. These two conditions need to give whenever you write the logarithm with a variable. Here a is a variable, a may be take any value, but here need to restrict this a value. A belongs to r plus a not equal to 1. In this case, log a to the base a is equal to 1. Now one example observe. Is log minus 2 to the base minus 2 is equal to 1, children? Because of your bases are equal, na? A is equal to minus 2. Is it correct or not? Very good, not a correct. Why? Because of here logarithms are not defined positive real numbers according to property number 1. Logarithms of negative numbers not defined. That's why it is not defined. First of all, it is not defined. That's why even though a logarithm of number with the same base, if you take also, it is not equal to 1. So that these conditions are very important while writing the property. Therefore, logarithm of the any number with the same number as the base that is equal to 1 if you restrict that number belongs to R plus and that number is not equal to 1. This is the fourth property. Now come to the fifth property. Logarithm of any number, logarithm of unity with any base is equal to 0. Logarithm of unity with any base. Sure, base with any base means we are not supposed to give any value. For which values of the A logarithm is defined, that values only we are supposed to give. That is, need to restrict A value also. A belongs to R plus and A not equal to 1. For those values only logarithms are defined. Log 1 to the base A is equal to 0. Logarithm of unity with any base. That base should be positive real number not equal to 1. In that case, log 1 to the base A is equal to 0. According to this, how can we prove it? Write it in exponential form because of A power 0 is equal to 1 or not? Yes, A power 0 is equal to 1 if A belongs to R plus and A not equal to 1. Then write it in exponential logarithmic form. This is the exponential form. Convert this is into logarithmic form. How can we convert it? Log 1 to the base A is equal to 0. Children, what is its value? Log 1 to the base minus 2 is equal to not defined. Why? Why it is not defined? Why it doesn't take 0? Because of logarithm of 1 is unity is there na? Why it is not defined? What is the reason? Because of if you observe the base is not a positive real number. That is the reason why it is equal to, why it is not equal to 0, and why it is not defined. The reason is A is not a positive real number. That minus 2 is not a positive real number. Now whenever we are using the logarithms, we have to keep all these 5 properties in your mind. What are those 5 properties? Let me explain again. Let me remember those 5 properties. First property is logarithm of the non-positive real numbers not defined. First one. Second one is logarithm of the same numbers with different bases are not equal. Third property, logarithm of the different numbers with the same base are not equal. Logarithm of the any number with that number as the base is equal to 1. That base should be restricted. That should be positive real number and not equal to 1 also. Last property, logarithm of the unity with any base. That base should be in the restricted domain of the logarithm. Base should not be negative and base should not be non-positive and base should not be 1. Now using this knowledge, I am taking one example. Log 243 base root 3. First of all, is it defined or not? Yes, it is defined. Why? It satisfies all the properties of the logarithms. It satisfies the definition of the logarithm. 243 is a positive real number, root 3 is a positive real number, and root 3 is not equal to 1. That's why this logarithm is defined. Now, if it is defined, what is its value? We are going to see it. Let it be some x. Now, write it in exponential form. Root 3 whole power x is equal to 243. Now, 3 power x by 2 is equal to 3 power 5. 243. What is its exponential form? 243 is equal to 3 power 5. Now compare, bases are equal. Whenever bases are equal and in between them is equal to sign is there, then the powers also equal. Therefore, x by 2 is equal to 5. That implies that x is equal to 10. This is aim number 1, children. In aim number 1, we have learnt the definition of the logarithm and where it is defined, where it is undefined also. So that using the definition of the logarithm, we are going to able finding of the logarithmic values.